Alright, first up, triangle proofs. Side, 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 angle, side, angle, side, angle. Angle, angle, side, hypotenuse, swag, or EQ. What information about two triangles allows us to conclude that triangles are congruent? We're going to apply our theorem to construct triangles and solve problems. Prove congruency using these theorems. Triangle rigidity included angles and included sides. Alright, what is triangle rigidity? Write it up. Alright, property of triangle rigidity. Huh? Gives us a shortcut to proving that two triangles are congruent. So check it out. Here is what triangle rigidity means. It means that if the side lengths of a triangle are given, triangles can have only one shape. Huh? Yeah, it's kind of an easy.
Every shape has one shape. Common sense.
Isn't how Cameron says
Rigidity.
Rigidity. Oh dear. LOL and rigidity. Alright? We're gonna get you down before this is all done, okay? So, our first.
Let me write that down.
Yeah. Oh yeah. Write this one down, guys.
Stop.
Our first congruency theorem is side, side, side. You might as well organize your notes like this. You might as well just make a list. Number one, side, side, side. Side, side, side theorem states, or postulate, whatever. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent.
You write all that down.
So much that you have to write down. I want you to think. Have you seen side, side, side before somewhere?
Yeah.
Yes. It was called the similarity postulate. And it said if three sides of one triangle are... See, this is why if you still say congruent, when I do like this, you're going to get messed up the rest of your time in here. Guys,
Proportional.
three sides of one triangle are proportional to three sides of another, then triangles are similar. If three sides of one triangle are congruent to another triangle, then the triangles are congruent. Big difference between proportional and congruency. Right, guys?
Yes.
Good.
No, do not go.
No.
Okay. Your second postulate is this. Okay? Oh, just kidding. Check it out, guys. We already know this. You don't have to write this down. Philip, get off your phone. Thank you. All right? I don't want you to go to Edmodo. I want you to look at the board. An included angle is an angle formed by two adjacent sides of a polygon. What in the heck are y'all doing? I'm trying to talk. You better watch the board. An included angle is an angle formed by two adjacent sides of a polygon.
You need to write this down.
No, you already wrote it down a long time ago when we did side, angle, side. Yeah, the SAS. The angle in SAS is included between the two sides. Okay? In this case, when we talk about side, angle, side, instead of sides being proportional, they are going to be congruent. Okay? So, side, angle, side congruency postulate says if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. Two congruent sides, one congruent angle. In between those congruent sides, side, angle, side. Right.
Hey, Tom, you're a great guy.
I tried my best, Cameron. I wish, you know what? I should run for president. All right, side, angle, side. Hey, y'all might want to write this down because we haven't talked about it yet. Hey, don't worry. Allison, don't worry. It's going to be okay. This class does not last forever, I promise. All right. An included side is the common side of two consecutive angles, I believe, in a polygon. Yep, there we go. Included side is the common side of two consecutive angles in a polygon.
Did you write that?
Yes.
Yeah.
You write that down.
Little chart thing.
Okay. So look at this. Hey, I want you to not only write it down, I want you to draw everything and write everything that's in there. Draw PQR and write this out. PQ is the included side of angle P and angle Q. Okay? Why is it included? Because it's between the angles. It connects the angles. Imagine included side. How would you get from angle P to Q? You'd take PQ, right? That's the side of the triangle. I might have a side and angle test in a triangle soon. Good for you, Cameron. All right. The angle side angle congruence postulate says the following. I'll go back later if you need me to. Check it out. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So we should be adding to our list. I have side, side, side. I've got side, angle, side. Now I have angle, side, angle. Okay? Should be adding to all of this, okay? Side, 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 angle, side. Now we've got angle, side, angle.
Already got it on the back.
Oh, bless your little heart. Okay? Alright, so I want to make sure we get this.
Oh my God.
What is the difference between side, angle, side, and angle, side, angle?
Wait, hang on, son.
Two
It has two
angles,
sides.
and there's one
Two
side.
sides.
Two angles and one side.
Two sides.
Yes, let's go.
Two sides.
Angle, side, angle has how many angles? Two with a side where? In the middle. Right? Side in the middle. Side, angle, side has how many angles?
Two sides
Two sides
with an angle in the middle.
with an angle in the middle.
That's a joke
Winner.
tonight.
Make sure that you keep this down. Got one more. Oh, I'm sorry. Oh, because that's what this class is. Alright. Hey, check it out. I got another postulate here. Angle, angle, side. Oh, it's a theorem? Pardon me. It's a theorem. Okay? Postulate, theorem, potato, potato. Tomato, tomato. Let's call the whole thing. Alright. So, angle side. This is something that some of you guys are going to struggle with. Two angles and a what kind of side? Non-included side of one triangle are congruent to the to the corresponding angles and the non-included side of the other triangle. Then the triangles are congruent. Stop. Hey, the difference between angle, side, angle and angle, angle, side is what?
The side is after both angles.
Say it again, McCroskey.
The side is after both
And
angles.
instead of saying after, we use the word what?
Before.
Nope.
During.
No.
Non-included.
Non-included. The side is not included, meaning it's not between the two angles.
So then wouldn't it just be angle theorem?
No. Do we say it's the angle theorem?
What?
Here's the problem with saying the angle theorem, Bradley. Very astute observation. Bradley, the angle theorem is only available for similar triangles. We're talking about congruent triangles. Very close, though. Yes, sir.
Observation, did you say?
Pardon?
What kind of observation?
Astute. Look it up. Here we go. Next.
I just never
I got one more theorem for you. Or postulate. Let's see what it is. Oh, it's a theorem.
Hypotenuse leg.
Hypotenuse leg.
HL.
If the hypotenuse and a leg of a right
Congruent.
triangle
Right.
are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. What kind of triangles can I use this theorem for? Easy. Right triangles and right triangles only. So we put a little star by it.
W-R-I-G-H-T.
No, R-I-G-H-T. Okay? Right triangles. Every right triangle, the longest side is called the hypotenuse. The side across from the right angle, the hypotenuse. Okay? If the hypotenuse, if the hypotenuse and a leg in two different right triangles is congruent, wow, then the triangles are congruent. Does anybody remember something called the Pythagorean theorem?
Yeah.
Remember, don't know what it is.
A squared plus b squared equals c squared, right? Nothing for you. You know why, Cassidy? Because you gotta say leg squared plus leg squared equals hypotenuse. Okay. Okay, guys, I'm moving on. Alright, let's talk about this real quick. Hey, no. Stop. Stop! Alright. See if we can use angle, side, angle in this particular theorem. Okay, I'm trying to use angle, side, angle. These sides are going to be congruent to the reflexive property. Is angle, side, angle available here? The answer is no.
It'd be angle, angle, side.
Why would angle, side, angle not be available? Because I have angles without the included side, correct? So, what would I use here?
Angle, angle, side.
Angle, angle, side. Okay? See that? Well, probably just throwing stuff in the back of the room, son. Move up here, right here. Let's go.
I'm confused. I'm sitting over here just listening.
Alright. Angle, side, angle. The side is where in relation to the angle?
Next to him?
Not next to them. In the middle. Between them. Included. Okay? That's why if I wanted to try and use angle, side, angle, it wouldn't work here. I'd have to use angle, angle, side. So you came up here with no notes, with no pencil, with no nothing. Go back and get your crap and come back up. Use side, side, side to explain this one. Are these going to be congruent through side, side, side? Yes. Okay, let's talk about why. Mr. Hobbs, you only got two sides. Au contraire.
There's words right there together.
BC is congruent to itself, right? Reflexive property. BC is congruent to itself. When you see that, go ahead and add those little tick marks. That way it'll help you out here.
Back there, Phil.
I got 1, 2, 3. 1, 2, 3. Is that good enough for side, side, side? 3 sides. Yeah, good. So you're already doing better. All right? All right. Woo! Wait. Use side, angle, side. Here. Here we go. I got side, angle, and then
Side.
stop. Nope. But look at these guys. The Bash Brothers. Side, angle,
Side.
side. Okay? Side, angle, side. Right? Where the angle is included between two congruent sides. Okay? Now, Myrick.
Oh. Okay, that's how it's fair. Give him the nuts.
What do I have now?
Oh, you got side, side, side. You got.
What's that? What's that?
You got side,
Angle.
angle,
That's
side.
an angle.
I got side.
It's X.
Angles.
So you got angle.
Oh gosh.
Let's go.
Is that gonna work?
No.
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 This is not
It's not gonna work, right? It's not gonna work. Angle,
You
side,
gotta use
side.
side, angle, side.
It's not gonna work.
You gotta use side, angle, side.
Gotta use side, angle, side. Okay?
So you put
So
side.
make sure that you see that. Okay? Alright. Proofs are things still. They're not going away. Didn't really give this one to you. Not gonna do much of it today. Okay? But just know they're not going away. They're still there. Okay? Oh, it's time.
Oh, it's time, ladies
Okay.
and gentlemen.
You got 30 minutes though. It'll be funny. Okay? And then, what about this one here? Hey,
Rebel Pride, 1968.
what about this triangle? It's been there longer than that, alright? What kind of triangle is it?
It has a right angle.
So what kind of triangle is it? If it has a
90
right
degree.
angle,
Stop.
a right triangle.
Let's go.
Stop.
It's a right.
I could have sworn I wrote this down.
It's so cool.
You should have.
Oh, hypotenuse leg. I got it right here.
I'm proud of you. Thank you for doing exactly what I've asked you to do. Alright?
You got 2 right.
This is called the hypotenuse. It is opposite of the right angle,
What's
right?
the leg?
Those hypotenuses are congruent. Where is the leg? What leg would be congruent here?
That one.
Wow. Okay? Yeah, this leg would be congruent to itself, okay? So I just need, remember, hypotenuse leg. It's going to be a thing with right triangles, okay? We'll talk about it over and over and over and over and over. And then we'll start figuring out the side lengths, okay? Hypotenuse leg. I only need a hypotenuse and a leg. It's the easiest one. And the giveaway is the fact that it's right angles.
You're bald. God, holy crap! I just noticed that. Like, you got hair right there, then you just bald.
Oh.
You guys are so rude.